Cool. Yeah, you could say hi in the chat too. Woohoo! Hello! How's it going, YouTube? Hello, Bob. Hello, Brent. Good to see you guys here. This is solder sesh number 10. Oh my God, we're in double digits now. Crazy. We got a lot of cool stuff today, I think. Oh, I should do a little intro for anybody that's new. Hello, I'm Carrie. I'm with Alpenglow Industries. This is Robin behind me scooting along. And we are the San Luis Obispo Alpenglow Industries, and we do electronics and projects. This live stream we do every week on Wednesdays, and the idea is to just, show a project that we're doing and do some sort of a project live. And feel free, we encourage everybody to also use this as time to work on your own projects and solder something of your own, or, use it as some cool scheduled time that you can just like make something that you want to make. So, all right. And, because it's after work hours and we're just doing fun stuff that should be kind of relaxing, we are drinking a beverage. And the beverage this week, I'm very excited to tell you guys about this. So this is, I'll do it this way, Two Broad Cider Works. They are a local San Luis Obispo cidery. And, it is started and run by two broads, two amazing, awesome women. And they're super cool, Maggie and Morgan, and they are making a lot of cider out of local or local-ish apples that are, sourced along the Central Coast. And this one is Push Mower. It is a hopped apple quince cider. So there's a lot going on in it, and it's delicious and very refreshing. I am part of their cider club, and so this was in the latest shipment. And really, what I did for this live stream was I went through all the bottles in the shipment, and I was like, 8.5%, maybe not good for live stream. 8.5%, maybe not good for live stream. Like one I think was like double digits, and I'm like, oh yeah, definitely not good for live stream. And so this one is a very nice 3.5%. So yes, that is awesome. Oh, what yarn are we going to spin? Yeah, so, okay. So yes, today is about tying up loose ends. Have I said everything about Two Broads? Oh, I will also say, so Two Broads is also just like around the corner from my shop, and which is kind of dangerous, right? And, but they also are amazing DIYers, and like Morgan taught herself how to weld and has been like making this amazing fence. They've been like really just working on their building and like cleaning up this outside area and planting this lovely garden. They're not quite open for tasting yet, but they're doing like a bunch in preparation for that. And yeah, they are a couple of people who have really just, done a lot of learning about the different things that they needed to do in order to like get this building all up and running and like be efficient at making cider. So awesome. Okay. Yes, today, what are we going to do? So we're going to tie up some loose ends today. Yeah. We're going to like stick a fork in some of this shit. So we're going to do three things. Going to do updates on the Nixie clock project, oh yeah, and the traffic light project. And we might even get around to soldering up the rest of the oscilloscope from last time. Maybe, we'll see. But those are kind of the three things on the table for today. So starting with the Nixie clock kit. Yeah, let's go to this view. So it is not on yet, but we had some exciting times this afternoon in the shop. So the first thing that I'll do is I'll kind of show you these tubes and stuff. And soldering these tubes in was a giant pain in the butt. And first of all, we left off at the point where we had done everything except the LEDs that are under the tubes. You can kind of see them through the tubes there, and the tubes themselves. And the reason was, so the LEDs under the tubes, they're RGB LEDs. and you can see that they have four pads that are all very close together, because those leads are very, very fine pitch. And so that just required some, magnification. And at the point that we did this, we didn't have a magnification set up for live soldering. So we saved that for later. And then the other thing was, each of these Nixie tubes is actually in a socket. So there's the tubes, there's the socket, and the sockets are what's soldered in. And we went through this a little bit at the end of the previous live stream, but it was a pain trying to solder those sockets in. We had ended up soldering the sockets in for this one, but then once the sockets were soldered in, it was almost impossible to actually get the Nixie tube in. These are used tubes, so they've already been soldered before. So first we had to make sure that a socket would fit on all of the leads, that there wasn't any excess blobby solder on there. And then, man, it's just I don't even know how to describe what it's a game of. It's just a giant pain in the ass, because trying to then get, how many leads do each of these tubes have? 12, I think. I think there are 12 per tube. They're arranged in a circle, and trying to get, and they're all, used and kind of bent in at different angles, and trying to get them all to seat in 12 sockets simultaneously, it was basically impossible. So we ended up actually taking the sockets out of the one that we had soldered in. We put the sockets on the tube first, and then you're able to more easily get the sockets through the holes in the PCB than you are to get the Nixie tube legs into the sockets. And that's mostly because the holes around the PCB are very smooth. So you can sort of you can sort of tilt it and start at one side and kind of get 3 of them in, and then you can kind of work your way rocking the Nixie tube into place, keeping pressure on it as you go so that the remaining ones don't just ping out, right? But because it's very smooth and level around the sockets, you can just kind of scooch the legs in with a pair of tweezers. But with the sockets, they have this conical, they have a conical entrance, but they have a lip around it. So basically it was just impossible to get all the legs in the socket, which begs the question, if I did have to remove one of these Nixie tubes and replace it, I don't know if the sockets are actually really helping, because it's so difficult to get the tubes into the sockets once the sockets are soldered in. I think we would just end up removing the sockets again, and then putting the sockets on the tubes, and then soldering the thing in as a whole. 12 ring leads, and they're really bendy. It's not like they're stiff in one spot. So they just, oh man, it was kind of a nightmare. And Robin did most of that nightmare. Thank you, Robin.
Once you get one in.
Yeah, that's no problem. Yeah. So we did all of those. Of course, we realized once we had soldered everything in that we had never powered it up to check the LEDs. And so we were like, oh God, I really hope we soldered all of the LEDs that are in the middle of all of those leads in correctly. And fortunately we did. So we powered it up, and we're like, oh my God, all the Nixie tubes are lighting up. It's so exciting. It's so fun. And then there was this loud bang. And both of us jumped a mile, and we're like, oh shit, what was that? And I'm like, okay, nothing's on fire. The tubes seem good. Pulled the power supply out, and then gently kind of went over to it. And it turns out that one of the tantalum capacitors had completely exploded. And I'm guessing that I had soldered it in backwards. That's usually what gets them. That or over voltage, but I think it was probably soldered in backwards. Yes, and so this is a screenshot. We posted a picture of it on Twitter. So yeah, that's what a tantalum capacitor that's exploded looks like, if you're curious, So anyway, you might notice that we don't have it on right now, and that's because we did power it up again. So we replaced the capacitor. I had another one, just lying around, and it was a 220 microfarad, 16-volt capacitor, and we replaced it with a 220 microfarad, like 35-volt capacitor, because that's what we had. So it's in. We very gingerly plugged it in again, and it all worked. And so, but we're still not quite trusting it yet. And we did check I checked all of the other capacitors before plugging it back in again, just to make sure that they were all correct, and they were. So I mean, I think we're good now, but here we go. And just a note. So this is just I think it's a 5-volt power supply that came with the kit, and I put an inline switch here. This is a good idea because even if you don't have exploding capacitors, because there's very high voltage running around on this board, and you don't want to touch that. It will shock you. And so being able to turn power on and off to the board without having to plug it in at the board and hold the board while you're doing that, it's a good deal. So yes, our little backdrop. This is just because there's a lot of crap in the background, and it's nice to have a nice white background. Okay, there we go. Yeah. Okay. So ta-da. Boop. Look at it. It's so beautiful. So we haven't done anything to it yet. Like Robin just finished soldering in the tubes. Uh-oh, do we have No, we don't have tubes out. Okay. So that's interesting that we're kind of getting some aliasing in the video here. That flicker that you see I don't think it's super apparent in real life. No, it's not. It might be, I wonder if they're PWMing the brightness or something, glowing in and out a little bit. Kind of looks like that. Or maybe it's just, ooh, that's exciting. It is actually doing that. So I'm not sure what all of these different modes are that it's kind of going through. It might just be an initial demo. We haven't actually done any setting of the clock or anything yet. So reading the instructions and figuring all that out is next. Oh, cool. I'm glad that the audio sounds good. That's awesome. We're switching it up so that you get different camera angles again. Oh, interesting. So Brent says, excellent. He's been doing my research for me. I like it. So he says that he was curious after I tweeted about the exploding cap, and he rewatched that part of the first solder sesh again, and wanted to see if he could see the polarity that I soldered it in at. And he says that he thinks that I had it in correctly from the start, and so that it is indeed mystifying. Yes, I didn't think that I had screwed it up, but I'm not perfect, and it was a long solder sesh, and I'm drinking beer and talking a lot, so I'm not fully focused as much as I could be on the soldering. But generally, things that are directional, I do check and try to do those correctly. So yeah, it might have just been a damaged cap, or maybe it got a voltage spike that was over the 16 volts or something like that. That kind of stuff can happen. So yeah, I'm not sure. And we did actually also, we beeped out the power before we plugged it in so that we knew that power wasn't shorted at least. So we did check that. But yeah, it's exciting. Oh, and it was also really funny. So it was a pretty small tantalum capacitor that was that 220, and so it was so tiny that it didn't have any of the normal vent lines in the top of the can, and so the entire can blew off. And when I went to do something else a few minutes later at the microscope, it was I turned to Robin. I was like, "Oh, were you looking at the can under the microscope?" Because it was just sitting right there, perfectly in view in the other microscope that we have in the shop. And she's like, "No, wait, what?" So it had just like landed there, and you know, it was like several feet away, but it was like perfectly like on its end, just like sitting there. So yeah, kind of funny and mystifying. All right. So let's see. Oh my gosh. Yeah. Bob says he built a dummy load that was basically a sandwich, 20 through-hole resistors as filling between two PCBs. Yeah, that would be hard. That would be definitely hard to align and get them all right. And he says that the build document suggested pre-cutting different lengths for each row, so the builder only had 4 to 5 leads to fit for each row at a time. Yeah, I was thinking about that, but also, you know, you have like a limited engagement depth in those sockets. And so I kind of thought about like, oh, well, maybe I should cut them on an angle and maybe that would make my life easier. But I was just afraid of, you know, having ones at one side be so short that they didn't make good connection in with the sockets. So yeah, I don't know. Hopefully these tubes will last a good long time and it will be a problem for later to replace them. But yeah, I'm happy. I'm definitely happy that they worked because, you know, I got them from a different vendor. I got the kit without the tubes. And because I think actually at the time that I bought the kit, it wasn't available with the tubes. And so I got the tubes like off of eBay from somebody completely different. So, and then they sat around in my shop for a while, for a few years, you know, moved locations, all that stuff. But yeah, I'm stoked that they're good. Yes. So yeah, what else? Like I was just gonna I don't think I'll spend any time like setting it or whatever here. We'll probably just like figure that all out on our own. It comes with a handy remote, which is kind of cool for aiding in all of that. Which I thought was it's kind of nice that it's separate from the board so that you don't have to be like touching the board in order to be setting something, right? You don't have to get your hands close to that higher voltage. So that's nice. And let's see, yeah, there were soldering instructions on the Nixie tube, blah, 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 problem check. But yeah, you basically just like, you know, press the different buttons on the remote in order to set like the time and stuff like that. And it has a little backup battery on it. So it keeps the time alive when it's unplugged. And apparently there's an alarm. Oh yeah, that's right. There's a little speaker on this thing, so we can make it into an alarm clock maybe. I don't know if I want a Nixie tube alarm clock. And then we can set the date as well. And I think there is even, there are these like audio ports that you can use to, I think maybe like hook it up to like GPS time, that kind of thing. And and then it has like an anti-cathode poisoning mode. That's kind of cool. When Nixie tubes are lit, when they're lit for any like length of time, they sort of like, you know, get this burn in. So the anti-cathode poisoning like reverses that. And that's actually built into the clock function too, which is kind of cool. So even in normal clock mode where it's displaying the time, it'll do that every 2 minutes and 30 seconds, it says. So yeah, anyway, kind of cool. Yeah, cool. Oh, and then the other one, yeah. So one of the audio jacks is for a GPS module, and the other is for a temperature sensor. So we could actually make it tell us the temperature too, which might be kind of fun.
Yeah, we could put it next to our humidity sensor.
Yeah, there we go. Then we'll have temperature. Oh, I wonder, can you change the units? For those of us stuck on the Fahrenheit time scale or Fahrenheit temperature scale, it's not that hard, but I don't have a reason to know much more than like 25 degrees C. So when somebody says like 42 degrees C, I have a hard time figuring out just how stupidly hot that is, right? I'm like, okay, I know that's stupidly hot, but I can't like automatically in my head equate it with something. So, oh yes, it does have FNC. Yeah, awesome. our little cheap like DIY humidity sensor thing does not have Fahrenheit, so
So it's practically useless.
practically useless. Yeah, cool. Thank you, Bob. Yes, I agree. It is very satisfying to see this completed kit. I'm stoked about it, and I really do like the LED underlighting too. I think it's really it gives it just a really nice extra glowy look. And yeah, I'm assuming that you can cycle through colors on that. I mean, right? Otherwise, why use RGB LEDs? So yeah, we'll figure that out too. Awesome. All right, I'm going to turn this off. And I'm going to go over to the traffic lights. So I will take this camera over and like let us know how the audio sounds during all this. So hopefully it'll be totally fine, but this is sort of second voyage for the lavalier mic, the first one where we're really moving around a lot. So woohoo, we have the traffic lights sitting up over here. Where they've been for a while. And so at the last time where we left off on these, I'm going to put this guy over here. Now we have scope view. Scope view. Cool. So the last time, I'm going to move this one over to so many cameras. So many cameras. We'll see how that is. I know we've gone through like 20 different setups here. So yeah, it's like, what are we doing? I don't even know. So yes, so we got traffic lights. We had added like a little inline key fob thingy, like one of those guys. And because we wanted to make it wireless, we wanted to be able to have like the traffic lights sort of mounted up high or something like that. And then have like a hand controller here with the buttons, or like maybe even with thumb buttons, or maybe we'll keep the big arcade buttons, but some sort of separate hand controller so that we didn't have to have like a wire connecting the two of them. And I thought like, oh, hey, cheap and easy way of doing this, 4-button key fob, that should be great. What could possibly go wrong? And then we wired it all up on like one of the previous live streams, and it was like, oh, this is being really finicky and flaky, and it doesn't really work, and like, what's going on? I don't really know why. And so we did a little bit of troubleshooting and have figured some of that out now. But if you guys have some ideas for what to like for solutions, I'm all ears. Well, we'll get into it, and then I'll tell you what I'm debating. So what is going on here? So what you're seeing on the scope here is actually, let's not do scope view yet. We'll do regular view, and maybe we'll put it in kind of normal mode right now. So we have a mode on this that's not game mode, that is just, on and off with the button press mode. And so I'll show you that right now. So we have red. Okay, that actually like worked pretty well, of course. It's going to behave now. Now since it's live, it's going to be like, oh, I'm fine. And so now we have yellow. And then we have green. You see, green is still kind of weirdly flaky, and not entirely sure why. Thought we had tracked it down to be a breadboard issue, but it may not be a breadboard issue. But the thing that you'll notice, and I'll stop talking here so maybe you can hear it, is that there's a delay between pressing the button and when the light actually goes on. The other thing that you'll notice is that it is much quicker to turn off once it's on than it is to turn on in the first place. The other thing that we noticed was that we can't have two lights on at the same time with the key fob, because basically the key fob is it only transmits one button press at a time. So as long as one button is still pressed, it is only transmitting that button press, and it ignores all other button presses. So that was interesting. Not that for our purposes, for the like the Simon Says game purpose, you don't really need two at once because that's not part of the game. Although I guess it could be. But it is interesting because it limits having other modes that just allow you to have them all on simultaneously, let's say. So yeah, there's the delay. There's weird flakiness on green that we still haven't quite figured out. That is so interesting. It was like totally working beforehand, and now like green isn't working at all. So yeah, not quite sure what's going on there. But yeah, there's definitely this delay thing happening. And so I'll put it back to normal like mode. And so now we can go to the scope view. And if I'll just run it here. So I'm doing a single sequence here because I want to be able to catch this, this timing. And we'll start a game because that's kind of the easiest way to see it. Although actually it might not be. Let's actually just do a button press. Yeah, there we go. So yes, we lost the game. Thank you. So, okay. Oh, actually it went off of single. Hang on. Let me do that again. Single. Okay. So we'll do a single button press. I think we're on yellow. Yes. Come on. All right. Well, now it got those. So what's happening here is that you can see, I might like zoom in a little bit here. So I want it so that you can see the edges. So what's happening here, we have the yellow line. What you're seeing on yellow is, sorry, I'm trying to undo my wires here. So what you're seeing on yellow is the signal that the processor is sending to the key fob. And then what you're seeing on blue is the output of the receiver end of the key fob. So the remote part, that's the output to the relays. So you can see that that it's delayed. And it's not delayed by the same amount each time, which is super interesting. So let's see if I can zoom in a little bit more on this. I just want to make sure that you can see that. Yeah. So yeah, you can see that there's actually, let me move the time scale over a little bit because it's easier to see on those two. So there's a pretty big difference in when the receiver actually turns on, like turns the relay on, between that first and second like pulse. And those are like the same length of pulses coming out of the Arduino. So what I think is going on is, so key fobs tend to be like very low power things, right? And they tend to have sleep modes and stuff like that. And granted, this is like on the receiver end, which you would think might be hooked up to a steadier source of power. But my guess is that it is not the that basically it is probably in like a sleep state for most of its life, and then it wakes up when there's a button press and then like does some stuff. And so my guess is that timing of waking up, or maybe it's not in a sleep state, maybe it's continuously polling, but it's polling at a kind of like a slow rate. And so depending upon where you are between polls, it it might be really fast to react, or it might be kind of slow to react. But there's always this like reaction time. But then the other interesting thing that you see is that there's a very consistent duration. There's a very consistent, very small amount of time between our Arduino basically turning that relay off and the key fob doing that. So that tells me that that there is sort of some event that is triggered by pressing that key press, but then once that key is pressed, it's like very rapidly, continuously pulling it until it's not pressed anymore. And so that's why it is like super reactive to the off, but kind of just sluggish and slow on the on. And so what all of this amounts to is two things. One, it's just like it's like kind of like this just a very crappy UI, because you press the button and then there's this delay. And for this game that's kind of like a little bit dependent upon reaction time and continuously speeds up, like having to wait between when you hit the button and when the traffic light lights up, it's disorienting and just like not pleasant. The other thing is that the overall amount of time that the traffic light is lit up is shortened because of that big delay at the beginning. And so it's sort of like barely lighting up, sometimes longer than others. And that's kind of bad too. And sometimes like it's so short that we don't even see the traffic light light up. And that's part of why it was like seeming so flaky when we originally did it. We're like, oh, sometimes it works, sometimes it doesn't. Yeah, it's all dependent upon that pulse width. So, but we don't want to make it on for a huge amount of time, because like you want the game to have like a nice cadence and rhythm and play. So basically, I don't think this key fob solution is going to work. Boo-hoo. And we're going to have to look into other ways of making this wireless. There are tons of other ways. I mean, we could add like Wi-Fi modules. We could add Bluetooth modules. I was trying to keep it cheap though. And when you start adding like Wi-Fi and Bluetooth, that could add like 15 to 20 bucks like on either side. And so I was just kind of like, oh, I kind of wanted to keep that mod somewhere in like the $5 to $10 range if that was possible. And like, maybe with a better like little key fob transmitter receiver pair, you could do that. I've never spun any of my own RF stuff at that level, so that would be a little bit of a learning curve for me in a project. Not a bad one, but that probably wouldn't happen anytime soon. So definitely thinking of something that's like a little bit more plug and play if possible. So if any of you all have any ideas, I am like all ears for that. And yeah, I think I'm pretty much done over here. I'll leave the scope view set up for right now, just so you can see it, but maybe we'll do this and go back to like talking head view. Cool. Bob's ahead of me on approximating between C and F on like a kind of intuitive basis by living in Germany for a while. Yeah, that would definitely do it. Yeah, anytime. I feel like I get much more of a feel for it if I'm in a country that uses only C, but it takes a while to get that like automatic kind of conversion going. Oh gosh, yeah, you guys are having bad temps in Arizona. Worst day ever, just reached 50 C, 122 F. Whew. It's been, I mean, even in San Luis Obispo, we've gotten some crazy record-breaking heat days. I mean, usually it only happens for like a few days at a time, but last summer was super brutal. And that with the smoke from all of the fires, when like all of California and like the West was on fire, basically, it made for like some gross days. I'm really hoping that we don't have another repeat of that this year. Like, knock on so much wood. Yeah. But yeah, definitely interested to hear if you guys have any ideas on like cheap little transmitter receiver pairs where I could like send 3 different button presses without a ton of delay. That would be cool. But in the meantime, maybe we will.
Over there.
Wait a minute. Oh, right. The parts, the actual parts. Yeah, that's a good idea. So it's not like totally in the way. It's crazy. Yeah, that is what I was ready to do. I was thinking of just like maybe chatting more while continuing to put together the DIY oscilloscope kit from last time. Oh, why thank you. My parts, madame. Get this guy out of the way. Put our tubes over there. I need to get a good enclosure for those Nixies as well. The board does have mounting holes in each corner, which is very, very nice. So we should be able to like, you know, find something or make something or build something pretty easily for it. Although Brent, I really liked how you used the Mystifier box, how you used the rails there. I thought that was like pretty darn slick and super easy and you know, nice and tidy. Didn't take up any extra space or any extra mounting hardware. So yeah, that was super cool. I definitely will be looking into using more of those boxes for projects in the future. All right. Yeah, down view. I'm gonna have to, hopefully we'll have enough light. We'll see. Oh, yeah, thank you. And oh, the other thing that we might be able to do is adjust our camera a little bit. Let's see. We can bump up, yeah, bump that up a bit. Exposure, need more exposure. There we go. Yeah, so I don't know about the whole you know, easy RF module sort of deal. I think my backup plan is to just, you know, maybe use instead of using the Arduino Leonardo, like use a Feather or something like that. It seems like the ones with integrated Wi-Fi, or it could maybe like ESP32 or something like that too. I haven't done much with them yet. You know, something with integrated Wi-Fi tends to be a little less expensive than the like, you know, Shield plus Arduino solution. But yeah, and not that it would break the bank here, but I just, you know, for somebody who maybe wants to repeat it or do some other project that's similar, it's just nice to be able to keep it simple. And like, there's not a big reason that we needed, you know, a ton of capability and like a full communications interface for this, right? Like we don't really need a lot of the capability of Bluetooth or Wi-Fi. So, so yeah, like having like kind of simple solutions that fit the problem is also something that I like doing and thinking about. All right. So, yeah. So Bob is also looking to add Bluetooth modules for Arduino and CircuitPython projects. Yeah, I like really haven't done a ton of looking into it to figure out like which one. There are a ton out there, so it's definitely something I could like spend a day perusing. There we go. That's maybe reasonably decent. Let's go a little bit more. Yeah, cool. Right on. So we have all of these resistors that Robin so nicely labeled. And oh, where did there's the instruction kit. Cool. And let's see. That's right. There was I think we had to look, maybe we had to look, oh no, here it is. There's a key on the instructions that they send with it that tells you which resistor is what value. Wasn't sure if we had to look online for that or not. All right, so since I have a 200K right in front of me, that seems like a good place to start. R3, which I found right away. No way. Over here. So maybe I'll do a couple more that are single values while I'm at it. Oh, yes. Wemos D1 minis are available in 5-packs on Amazon for about 15 bucks. So I just picked up some of those. So yeah, those are ESP modules. And yes, I just picked up some of those, just starting to learn about them. Haven't used them before, but yeah, that is a good idea. Thank you for reminding me about that. Thank you for bringing it up. Yeah, because those are super cheap, and yes, from all accounts, they're pretty easy to integrate with, and they integrate like straight into the Arduino environment, and you can like, you know, reprogram them via Wi-Fi, which is kind of cool as well. So yeah, you could actually have, you know, a wireless link between like your computer and the controller, and then the controller and the traffic lights themselves. Yeah, that's a good plan. Brent likes the Raspberry Pi Zero for Wi-Fi projects. Ooh, $5 on sale from Micro Center. Oh, that's good too. I haven't played around too much with the Pi Zeros. We've played around like a little bit with the main Pis, which of course are kind of like big and, you know, more power hungry, right? But yeah, I haven't played around much with the Zeros. I don't even know if I have one around here. I feel like I must have like one of everything, it seems like. Although probably not, because there are so many things out there. It would be hard to have one of everything these days. All right, R38. Ooh, found that one too. All right. That guy's over there. It's a 1.5K. And let's see. What about R11, 150K? I think those are all the singles that we have left. So, oh, 150 ohms. Sorry, not K. R11. There you are in this big long stack there. Cool. Just making sure I'm reading these right. Yes, in this long stack, the reference designators are on the bottom of the resistor that they belong to. Sometimes when you have a bunch of things in a row and something is like on the top or on the bottom, you can get like mixed up mid-row and think that the reference designator is on the top when it's on the bottom, and then you can get one off, and that's no good. So that was just why I wanted to double check that. Cool. All right. David Watts from the UK has a YouTube channel where he solders a lot of things. He frequently uses Wemos D1 minis for his projects. Cool, that is good to know. Awesome. Yeah, the project that turning the soldering iron on would be helpful. Fortunately, it heats up fast. No big deal. Yes, so the project that I got it for. Oh, hey, I can show you this because we have like mobile cam right now. So yeah, we can. Oh, are we still? Yeah, there we go. So we've been working on like the wall art in this room. We have this cool print that I had framed, and which has like interesting like circuitry kind of things on it. But we have this other thing, which is this sort of funny piece of vinyl wall art. So new and improved, whole to another universe, now with LED lights. And so, you know, of course, the LED lights being just the red dots that are around the black hole. But the thing that we want to do with this is we want to put one of Jason Kuhn's Fibonacci boards in the middle of the black hole so that we have, you know, a spirally lit up, sucking you into it and hypnotizing you black hole. So yeah, anyway, So that's what we were thinking about, using the Wemos D1 on, putting it on the back of the Fibonacci board so that we could make it battery powered and just like stick it in the middle here, which, we kind of went back and forth. Like, yes, it would be nice to have it like just plugged in all the time and not have to worry about charging and recharging, but we decided from an aesthetic perspective that we would rather not like have a cord like, spaghettiing around there. So anyway, that's our little project that we'll probably, showcase on the live stream sometime, because that's how we do it. Camera down. All right. Mobile camera is now out of its holder. Woo. Cool. Okay. So yes, back to soldering. The challenge Bob has with Raspberry Pi of any model is availability. Yeah, it's hard to get any quantity of them, and they go in and out of stock pretty frequently. Yep, that is the case. The other thing you might notice right now is that we have like an iron with a pretty fat tip on it right now. And that's because we had mentioned last time that there's a BNC connector on this that has like some pretty big metal heat sinking to the like the shield, and that you actually like have to solder onto the board. So we are going to need some extra heat output capability. And this tip that you can see, it's basically a screwdriver tip, and yeah, it has like maybe like a 2mm tip or something like that, 2mm wide tip. So it is able to transfer a lot of heat to the pad and to the board. So it's really great for anything that would otherwise just suck all the heat away. So soldering to planes, soldering big components with the shields, like the BNC connector, that kind of stuff. There are even bigger and fatter ones that we could use, but we also wanted to be able to solder resistors with them. So, we kind of went for something that split the difference a little bit. I'll put this in this way. It's a little easier. Cool. Yeah, and I have to say, so this is just totally like a personal thing with the Raspberry Pi, but I come from I come at programming from a much more I'm like much more comfortable and more easily think in low level languages. So, C I'm pretty good at, and programming things for like small embedded processors I'm pretty good at. When you start to get to things with operating systems on them, I am less good at that. And there's like a lot of overhead and rigmarole and other things that you have to like think about and deal with that are not my favorite for embedded projects that just need like a small bit of functionality. And like, that's just a personal preference thing. I'm not like trash talking Raspberry Pis or anything. Like, we use them for other projects around the shop for sure. And, they're great for, they are, yeah, we made this is actually a project that's up on Hackaday. I should be putting resistors in while I'm talking. I am putting in a 300 ohm resistor. Oh, this is a single one too. They just gave us two. So R6 is 300 ohms. So yes, we made, so we got one of those like little thermal label printers for printing shipping labels, and it's awesome. It prints super fast. It's way cheaper than laser, than using a bunch of laser toner and buying the labels and stuff like that. So it's awesome, but they're only USB connected. And this is actually I just realized it's totally like living its life right next to a computer with plenty of extra USB ports right now. But in our previous shop, it was like the shipping area was not conveniently located by like computers and power. And so we didn't want to like drag a computer out there. And it was also like really, really dusty and stuff like that. So because our old shop was like right next to like a concrete and block making like place, so it was like rock crushing was happening next door. And so anyway, we didn't want to have a computer in our shipping area. We just wanted like the USB to be Wi-Fi enabled, and so we hooked it up to a Raspberry Pi and did like a whole bunch of learning and internet searching and stuff like that, and using other people's open source stuff to like turn the Raspberry Pi into a print server, and then to also make it like that was actually relatively the easy part. The hard part was like then getting all of the various different eras of Windows computers talking like happy with drivers and whatever to both see the printer on the network and be able to print to it with like the right settings. That was like a whole nother thing. But we wrote up the entire thing on Hackaday, and it's very tongue-in-cheek because that's at the point that I was when I finally wrote this up. And it was like one of those things where you solve one problem and like 20 more pop up.
Yeah. That definitely was kind of a never-ending project there.
Oh my God. It took us a few days and a lot of cussing. A lot of cussing. But I like once we figured it out and got it working, it's like it doesn't require any care or feeding. It never fails. Of course, it's going to screw up tomorrow now that I've said that. Sorry. But yeah, it's like it's super bomber, and it's nice to be able to. It's still nice to be able to print to it from any computer and stuff like that, I will say.
Yeah.
So, which I mean, we could do as long as it was attached to another computer that was plugged in and on the network and blah 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 blah. But Raspberry Pi, man, that's what they're great for. So R7, R36 is what I'm working on placing and soldering in, and I feel like R36 should be around here. Ooh, where are you, R36? But yeah, I would just say like for projects that don't need the complexity of an operating system, I prefer to not have the complexity of an operating system. That's mostly it. Oh man, R36 is evading my vigilant gaze. I know, right? I know, like R35 is a surface mount one down there. R37 is up here. R39 is there. R40 is there. I don't think I am covering. R36. I probably was covering it just a little bit. There we go. Over. Yeah.
Yeah.
The focus on the workbench is a little weird. Okay, let's see if I can fix that a little bit. I feel like,
I feel like it's trying to focus on like the top of things.
Maybe let's. Yeah, I wonder. Oh, instead of I see what you're saying. I wonder if I can manually focus this. I don't know. Focus. Not manually focus. Is that any better? No. It's interesting. It is better on the camera's LCD. Oh, whoa. Okay. That was, interesting. Yeah, sorry about that, guys. Usually, I feel like it was better in previous weeks.
Maybe it needs more light.
It might need more light. Sorry, making you sick here. Ooh, zooming in and out. Yeah, manual focus is not very helpful on that. Yeah. All right. Okay. Manual focus is off now. Oop. See if I can fake it out with the hand. Yeah, it's better. Let me. Oh, we don't have the other light there. That's okay. All right. Well, we don't have any more lights that are easy. I don't think to clip on. So, yeah. Unless, oh, there's this little thing, but I don't think I have anything to really put it to. Yeah. Huh. Interesting. I feel like maybe it's the red board actually, because the other boards that we were doing were had more contrast, had more black and white, right? Were like white on black and stuff. So yeah, pretty much all of the other boards that we soldered actually have been black. That's an interesting observation. So yeah, we'll try and figure that out next time. There's always something.
They can see what we're doing.
Sort of.
Yeah, not good enough to
actually read it. Yeah.
Thanks, Bob.
Yeah. Yep. R40. Oh, I totally saw that. Where were you? I think it was down here somewhere.
Yeah, you said here's R40.
I know. I did last time. R39. R37. Oh, I totally had you. Where are you? Oh, there it is. Sort of in the middle here. I'm not sure if I believe that that's only 3.5%. I'm just saying. For the record. Maybe it's a typo. Maybe that one's 8.5 as well. No, I don't think so, but all right, let's see. We got these guys all more or less plugged in. And let's see. Do those guys first. Cool. Awesome. So yeah, does anybody else have projects going on this week that they've been working on, or projects they wish they've been working on? That's totally legit too. Like, I haven't been working on this project, but I wish I have. I tell you, I am glad to finally have stuck a fork in that Nixie clock kit. It's very exciting. I guess we shouldn't say we've stuck a fork in it yet, because we still do have to make it into an actual clock, right? So it's not over.
It doesn't explode. What more?
Yeah.
What needs to be done?
Right. Turns on, doesn't explode. Standards are low. I don't know how much you guys probably can't hear Robin very good since I'm using like the lavalier mic, but yeah, that's what she was saying. Yeah, apparently we need a dual lavalier setup now for the lavalier days.
For my hot takes.
That's right, yeah. For your hot takes. Hell yeah. Can't get enough hot takes. I mean, between your hot takes and my hot takes, maybe, some of them are actually hot takes.
Yeah. Some worthwhile commentary.
Right. All right. What else do we have going on? 1.9 mega ohms, huh? Oh, 1.8 mega ohms. Yeah, close enough. R2. I definitely saw that one over here. Do this. R2. trying to think of what else we have going on here. Oh, so like in a week, I need to double check with him because he was working on some stuff in preparation to like maybe show off some new stuff. But next week, tentatively on the books for Solder Sesh is Tommy from OskiTone. He makes a bunch of really cool, fun kits. Definitely check them out if you haven't already, and we'll leave some links too. But yes, he does amazingly fun, silly, noisy things with 555 timers. So we'll be putting together his APC board, Atari Punk Console, I think is what it stands for. So it's going to be like all sorts of lo-fi 8-bit, like really the sounds that my mother like hated. Yes, annoy your parents. I don't know. For some reason, my mom had like she hated the 8-bit like video game noises of the 1980s, which was made for some strife in the household. But that's basically why I wasn't allowed a Nintendo console when I was a child. And I am scarred by it. Scarred, mother, I am scarred. And that was not the R10 position. That was the R9 position because the reference designators are on the bottom of the footprints. Weren't we just talking about that? Don't get confused mid-row. Okay. But yes, I had a Nintendo Game Boy. That was what I was allowed. That was for compromise. I could have a Game Boy. It's the first model of Game Boy that came out, original Game Boy, black and white. And it had like a little headphone slot. And so she made me wear the headphones a lot. Yeah. Which is not nearly as satisfying as like having it around. Yeah. Bob says, yay, Tommy from OskiTone. And yeah, is interested in the Poly 555. We might have one of those here. And so, maybe we need to work on our piano skills for next week.
Yes.
And yes.
Maybe like retune it because I'm pretty sure I used some cheap app to tune it. I don't think it was very good.
Robin says she used some cheap app to tune it and she doesn't think it was very good, so maybe it needs a retune. But yeah, I think we definitely need to practice and have a Poly 555 recital. I feel like I need like a one of those like jackets with tails.
Frilly collar.
Ooh, frilly collar. I like that. I like it. 20K R5. Yeah. Let's see, where are you, R5? R1, R4, R8. Oh, is that an 8? Yes, that's an 8. Oh, old eyes, old eyes. Where are you, R5? Where are you? Ah, God, sorry. And this is where everybody stops watching. What else? So yeah, that's going to go on next week, hopefully. Although if he's, so yes, there's hopefully going to be some demo of something new, but if he's not ready yet, then we're going to postpone it to when he can show off some new stuff too. So, but tentatively and hopefully he'll be ready. If not, we'll put together something else. Yeah. Dang, I am having a hard time finding. Oh, maybe this was an extra one because R5 is already soldered in, as it turns out. Would you mind grabbing a multimeter and with the pointy probes so we'll just check that and make sure that it's
with the pointy probes?
Yeah, not the clippies. Yeah. Doesn't have to be super pointy, but just any type of the pointies. Yeah. Yeah, because they do give us extras of a few of them, and so yeah, that might have just been one of the extras. They kind of got loose from their partners in transit. Okay, R37 and R39, these are 10K resistors. Whoop, do this. And there we go. And R39. Make sure you're there. Okay. And now we're going to use the multimeter to measure R5 and make sure that we have the correct resistor in there. Yep, 20K. So we are all good. Cool. Must have just been an extra. Always good to check. Okay. And let's see. 120 ohms, R8, R12, and R13. I might just try to put the rest of them in, maybe. We'll see. This guy is R8. Oh. Oh. So Bob says that maybe the reason my mom hated those noises was because they were square waves and they have odd harmonics. Yep, included with the bass frequency. That is true because, like, you know, a pure frequency, a pure tone is a perfect sine wave, and the way that you basically get a square wave is to sort of like add up a whole bunch of sine waves at kind of various amplitudes, and the sum of all of those things then approximates a square. And so when you think about it, you know, you have your main frequency, but you have all of these other like just off frequencies as well that you're hearing when you hear a square wave. So yeah, that's kind of why it sounds all weird and distorted. Hang on, R12 and R13. That one is R13. And the bottom one is R12. And so, yeah, Bob says he wants to build some simple low-pass filters to optimally remove those harmonics from a 555 or other square wave audio to adjust the sound. Yeah, that would be cool. That would definitely be like a cool little project. And yeah, kind of like another fun way to make noises. There's so many good fun ways to make noises. All right. So now we're going to solder all of these guys on. Maybe put that there, get most of them. And solder this guy over here. Solder this guy.
That tip seems to be working well.
Yeah, no, the tip is great. It's like definitely puts out a lot more heat than that really pointy one that we were using last week.
Yeah. Probably don't need it up to 800.
Yeah, probably don't. But I mean, it's fine there. It just makes everything go super fast, which is kind of the way that I like to solder personally. I like it when I don't have to dwell on a pad for very long.
Yeah. Makes me feel like I'm doing something wrong if I have to sit there too long.
Yeah. Yeah. It's like I kind of worry about overheating pads more, definitely when my dwell time is longer. All right, get rid of all these little ends.
Dang, knocked out those resistors.
Getting there. Got one more.
One more?
Yeah, one more value of resistor. And then I think we can do the connectors and then do that BNC last because it kind of sticks up and is bulky. So I don't want it like interfering with other stuff.
So which are 1K or 100K extras?
We might have two. Then we have two. Yes, I didn't see the 100Ks there. Cool. So yeah, got 3. 1Ks are 9, R15, and R26. are 9 or 15. So this one's our 9. And our 15 is pretty close right there. The real test will be if there are any ones that are still unsoldered after we solder in the last value. And our 26. So I think I'm going to solder those in place now. And this one. Nice. I'll be excited to try this little scope out. It's like not bad, like 200 megahertz bandwidth was not bad for like a tiny little scope like this for $20.
Yeah, I've only seen, you know, I think the one you used to show the lights on is the smallest one I've ever actually like seen in person. So. Oh,
we do have one of the, we do have like a pretty tiny one. It's actually probably smaller than this one.
Do we?
We do. It's, actually, I think it's here now. It's in a drawer. But it's a, what is it? A DSO. It's the one by Seed Studio. I forget what the number is on it. But it's like, it's DSO something or other. And it's, you know, it's smaller than the size of this board and is black, and it's, you know, it's fully assembled with an enclosure and a screen and stuff like that. And, but it only has, well, I guess this one only has one input too. So it's a single input, and it has like maybe 4 different buttons. The UI isn't great. I feel like the bandwidth was not 200 megahertz though. I feel like it was smaller bandwidth, so you couldn't see as fast of signals with it. But yeah, it's pretty good for just like having on your desk, like right next to something that you need to just quick get some eyes on. And it also comes with, it also came with some little probes that are like breadboard jumper adapters, which I thought was kind of cool. Just made it super useful. All right, R1, R4. This one's R4. And R1. Bend this properly. Come on. Trying to get it centered there just because I'm, you know, want it to look nice. And then R14. Let's see. All right. Well, those were the ones that I knew were missing. I think that's everything. I think we might have gotten all the resistors. Yay. Oh, I forgot we have that fine pitch USB one too. That might be a little tricky with this iron. We'll see. We'll see if it can be done. And then over here. Cool. And awesome. Cool. Ooh, we have a crystal.
Oh, a second crystal?
Oh, that's right. We went through this last time. They gave us 2 crystals, but there's only one on board, so we think it's an extra part. So we can do connectors or buttons. I think connectors first and then buttons because they kind of interfere with where we're holding the board. So I'm just going to put those two in, and I'm just going to like hold them in and try to, it is tricky to keep these straight. I'm going to do it one at a time. And I'm just going to do the solder blob. Oop, don't burn yourself.
Yep.
There we go. Don't burn yourself. So I'm just going to do like the solder blob technique to get this one tacked down. And if you flux the pins ahead of time, or the pad ahead of time, then this technique actually works a lot better. So I might do that a little bit here, because then it'll actually, then the solder will actually flow. Okay, so now it's in straight. These ones also, the sockets you can kind of feel when they're seated, when they're straight and seated properly. So this really is just not wanting to tack down. I wonder if that's because it's a ground pin. Maybe it is. Maybe I'll try the other pin. Oh yeah, that was better. And now before I do the other side, I just check to make sure it's pretty straight, and it is. So I'll go back and go over this pin, and then go over this pin. And there we go. And repeat the process for the second one. And there we go. It's pretty straight, not wiggling. So then we'll finish soldering this guy down. Cool. Bob says a dozen or more kits later, he's definitely getting better with his soldering technique. Yeah, it's just practice. It is just practice, like anything. And I think also once you know like why you're having certain issues maybe, and like what to do to fix it, that helps too. All right, I'm going to do this long connector. And this one is pretty, since it's like so large. Boy, this camera's really, having trouble focusing. Because it's so large, it's pretty easy to hold down flat. You can just really tell when it's, when it's like fully flat and touching all the sides. All right. I think another thing is that, that's super ugly. That's great. I'm going to tuck that one down, and then definitely look at this and make sure that I'm pretty straight before going on to solder a bunch of other ones. I'll reflow this one first because it was so terribly ugly. And again, make sure that it's all straight, looking nice. And then go down and solder the rest of them. And I'm going to turn this so it's just, a little more ergonomic for me, and so that it's at like a decent angle, so that I can just kind of go and solder down the line. Yeah.
Bob says he might try your blob technique next time.
Yes, I definitely encourage you to try the blob technique. It's very helpful for just holding things in place for long enough to be able to like make a few good joints, you know, and then I feel like, yeah. Well, I have like one end of this connector. I don't know if you can see it here. It's just like a little bit on the high side. It might be hard to see there, but it's not terrible. What I can try to do, see if I can get this at a good angle so that you can see it. So I can basically just try to like kind of press it in and like kind of go down this row and like reflow a bunch of them at once. And like while I'm pressing in, yeah, it's not really gonna do it. It's not enough to be, it's just enough to be like personally annoying. It's not enough to, I don't think, be an issue. So yeah. But yeah, I should have looked at it from both sides actually. So for long connectors like this, that's something that can happen because they're so long that like you'll get one side tacked down, but then you know, the other side will be a little bit lifted or something, and then that can cause your whole connector to kind of be cattywampus. So yeah, for the big long ones, it's good to check them from multiple angles. There we go. So yes, so Bob says that one trick he has is to like get larger components tacked in, then press the item in while he reflows the initial tacks to better fit the components. Yeah, and that's what I would have done if I had noticed at the time of the tacks that that it was a little bit askew, because that's definitely like, basically I'd already soldered like kind of 10 pins down the row or something. And so at that point in time, it's very difficult to fix anything because you have all of these pins that are keeping the component in place. If it's only 2 or 3, sometimes you can like blob between them and kind of reflow them all at once and get it to move down. But yeah, in this case, there was just kind of too many pins and too much space between them to really be able to do that. Yep. Going down. I wonder how many pins are on this connector. 40, it says. Yeah, it sounds about right. It's nice that they put the pin numbers on the back. I mean, hopefully you shouldn't ever have to troubleshoot the LCD, hopefully. But especially with connectors like this that basically are like totally symmetrical, and it's difficult to necessarily know what pin you're on, like marking the pins every now and then is kind of nice. So you can see in the silk screen that they've marked them all the way down there. Cool. Well, that looks like it's in. Now, let's see. Let's do the switches. Switches now. So the switches are going to be kind of nice. I'm going to see if I can clamp this over here maybe. And now I'll do this. So these switches are nice because they kind of snap into place. They have these little, oh, that was interesting. The video froze for a second. they have these little pins that are bent, and so they make these like little bumps that help like retain them in the PCB once you've put them in. But you do want to then make sure that like you get them all the way in and that they're flat. But yeah, and switches like this are not directional or anything. They basically switches in general are sort of like set up to be chained. So the bottom two leads will be connected internally, and the top two leads will be connected internally. And then when you push the button, the top is shorted to the bottom. So that can sometimes make routing a little bit nicer with switches, because you can like, you can connect to either of the bottom pins and get that signal in and out. So you can actually kind of use switches as a as a mechanical jumper if you need to. Cool. Awesome. All right. So these, I thought there were more switches than those, but maybe not. I guess not. Cool. They gave us 2 extras. All right. Yeah, these pads are soldering very nicely, especially the ground pads. So that's nice. They're a little bit bigger, so I'm feeding a little bit more solder in. Awesome. All right. So I think USB and BNC is all we got left.
Wow.
Yeah. I'm going to try soldering the USB with this one. It might not go very well. So we'll see. And that's just because it's so small. Well, it's such fine pitch for a through hole component. Might have to go back to the other. Might have to go back to the other iron to do this well, but we'll see. I'm also.
Is that metal?
Yeah, so there's a shield. Well, so I'm not going to solder the pins that are attached to the metal can right now, because yes, I would totally burn my fingers. And you can, I mean, you can get like little rubber finger cuts and stuff like that for this kind of work if you need to be touching something that gets hot while you're soldering. But for this in particular, I think just soldering like one of the pins first will be fine, and then yeah. Oh, there we go. Pachoo. And I'm checking this from a few angles now. So I'm looking at it there. I'm looking at it there to make sure it's flat, and it is. Yeah. So yeah. So I think that this should be fine. So now I'm actually going to solder 2 of these shield ones. So now it's like very well held in place. And I'll solder the other 2 shields. Almost. All right. Because the way these pins are laid out, I'm actually able to do this with this big fat tip without shorting them out. And that's because I don't have to get the tip near any of the other pins because I can approach them from the side. So I was actually able to do that with a big fat tip, which is nice. Yay! Didn't have to change tips. Cool. All right, last one, the BNC. So this guy goes right here. And again, just a refresher, we have to solder these two pegs in on the bottom, and you can see that they are directly connected to like this entire connector body case. And this pin will be pretty easy to solder in because it's just the center conductor. But this, not only is it connected to the entire body of that connector, but it's also connected to ground on the circuit board. So we have like a lot of things that are going to be sucking the heat away from us when we go to solder this. All right. Now let's see. I want to hold this in. Yeah, I think that'll work. So I'm basically going to hold it in briefly by the center conductor, if I can. I think this big iron is making it a little more difficult than usual to just tack things down. I think because the flux just like dissipates so fast because it, conducts so much heat. So I have a little better time with that tactic on with smaller tips. But let's see, what do I have around here? So I'm just going to kind of prop this on something. It's like kind of stuck in right now. It's actually not really going anywhere because I think that these pegs are really, these two pegs are a really close fit. So they're helping keep it in the board. But I'm just going to, and I have like a bunch of other components on the back of the board here that are sticking up. So it's hard for me to like press this against something. So, I do just have this like clamp that's kind of lying around. So what I can do is just make sure that just kind of like prop it on that while I'm soldering, just to make sure that there's like a little bit of pressure down on this. Yeah, and I want to put it over, like cantilever or rotate out. Making sure it's seated. So now I can solder that middle one and like check to make sure it's good. It's looking good. Looking good there. And on the bottom. Cool. And so now I can solder these ones. And like, yeah, you'll notice that even with this big fat tip, it's taken a lot to reflow this. Pretty long dwell time there. And like sometimes you'll even feel through the board like the copper getting hot, which I do a bit there. And again, solder can help conduct that heat. So like, getting a large ball of solder on the tip and letting that do the work for you is also perfectly acceptable technique in that circumstance. So yeah, I definitely wouldn't have been able to do this with the tip that we were using last week. Not at all. Not even a little bit. And because there was like a bunch of flux there and stuff like that, that's like a little bit now burned around the board. I'm just gonna like clean that off a little bit with some isopropyl. Mostly an aesthetic thing because it is no clean flux that oh no, it's actually rosin. It doesn't say that it's no clean. No clean is technically a type of rosin, but usually it says no clean if it's no clean. Usually just rosin means RMA, rosin mildly activated, which leaves a little bit of sticky stuff. All right. There we go. Woohoo. Let's see. Whoop, wrong way. All right. So we'll see now if this plugs in. Hopefully it does. I'm just checking right now to make sure that none of these pins are bent, because if they were, it would make it difficult to insert. So they all look good. I'm going to kind of line up this 40 pin guy first. I can feel it in, feel those two in. These two look good. So now I'm ready to press down. This connector is still hot. And yeah, I'm going to kind of focus on that side first. Perfect. There we go. Cool. All right. DC 9 volts. I don't think this kit came with a power source. So I don't know if a 9-volt battery is going to be able to source enough current for it, but we can try. We can check it out. Let me see. Let's see. We got that. We got that. Just looking at my parts here. All right. I am going to grab a 9-volt battery and be back. Cool. And I know you can hear me shuffling around the shop back here. Lavalier mic. I'm actually like looking. I have some miscellaneous power supplies, and I feel like power supply bricks, and I feel like one of them might actually be 9 volts. So I'm going to see if that is indeed the case. 9 volts. Nice. Oh, 9-volt AC. Not nice. I think that must have been from like an old phone or something. That's interesting. 9-volt DC, 500 milliamps. That should be fine, I would think. Cool. And also making sure that it is center positive. Yes. Awesome. Cool. Hello again. Thank you for waiting. Yes, 9-volt battery will work. Oh, cool. Cool. Sometimes, I'm not so sure, especially like with a largish LCD on here. 9-volt batteries generally can only like source about 200 milliamps. So I wasn't too sure if it would fit the bill or not. All right, plug this in. Let's see. We did not have any tantalum capacitors on here, so hopefully there will be. Oh no, there was a tantalum capacitor. There were some on here. So you know what? In the spirit of having had something just blow up on me today, I'm actually gonna, let's see if I can take the LCD off without like totally tweaking it. So like once it's in, there's like a lot of retention force. So you want to be really careful about like slowly wiggling and more or less pulling straight up, because if all of a sudden one side releases and it goes like this, you can like bend the crap out of all of your pins, and that's no fun. Okay, so yes, and also before we plug in, I think I will beep out power, because that's also a good idea. Also a good idea, just to make sure that your power isn't shorted. So beep mode. All right. In general, the back one here, so let's see, you can see that this is the power connector right here. And the back one is generally the center conductor that comes out of the back of, you can kind of like just sort of barely see that there between the connector. So the center pin comes out the very back, and that one is usually positive. And then it depends upon the circuit board designer. Like one of these is actually connected to the metal barrel. The other one can sometimes be a switch that tells you whether or not you actually have a connector plugged in there. So, so one of them can be floating and one of them can be ground, or sometimes both of them are ground. It sometimes just depends upon the circuit board designer. So we will just make sure that we do not have any beeps between power and either one of these. Yes. And we also verify that we are beeping when we are supposed to beep, because there's nothing worse than having your multimeter go to sleep and you not realize it, and you beep something out and you're like, oh, look, it doesn't beep. And then it's shorted and it was because your multimeter was asleep. Not that that's ever happened to me. All right. And now, because paranoia, healthy dose of paranoia is good, we will now also visually check the tantalum capacitors, because like you definitely wouldn't want one of these like exploding underneath your LCD. That could actually like damage the circuit board. Okay. So another way we can do this, most of the time, the negative terminal on tantalum capacitors is going to be connected to ground. So one way that you can check that they're in the right orientation is by beeping out ground. And like, I'm going to make sure that, oh, that's interesting. That is not the same ground. Or, whoop, there it is. Yeah, it is. Okay, cool. So it's always helpful to have some handy, easily accessible ground points on your circuit board to beep out stuff to. So I was just making sure that like the power supply ground was actually connected to that B and C connector, because that's a really easy thing for us to probe to as a ground reference on the top side of the board. So, or the bottom side of the board, either one, because we're actually going to have to probe on the bottom because these are 3-hole parts. So we can see. And the reason that we would want to do this is because the pluses are not, some of them are like kind of barely visible, and it's just a general good double check too, you know? So, I mean, I'm looking at all these. Okay, it looks like there's a little plus there, which is at the plus side, little plus there at the plus side, plus there at the plus side. This one plus there, which is the plus side, and that one is there, which is the plus side. So I think we're all good. But another way we can do is, if they are all actually connected to ground, which they may or may not be, you can also like beep out the bottom. So yeah, this one, whoop. That's interesting. Oh yeah, okay, so that's right. So that theory does not hold for this board. Why does it not hold for this board? Because this board has negative voltages running around it. That's why. So some of these tantalum capacitors, the positive side might actually be connected to ground, and the negative side will be connected to a negative voltage rail. So yeah, so we're just going to have to rely on the markings on the board. We could see all the markings, so that's good. Yeah, I kind of, it's been a while since I've worked on a board that that had negative voltages running around, because yeah, most of the things that I work on are just like 0 and 5 volts or 0 and 3 volts. So yeah, sometimes you forget that the negative side of something can actually be ground. But yeah, so we'll just rely on the markings to be right. I've probably blabbed on long enough and procrastinated turning it on long enough. So heck, let's do it. So we'll do this, making sure that we're not one off. Again, we'll press down. We'll try not to press down on the screen itself. Okay. Those are all good, properly seated. Bzzz. Ready? Oh, hey. Attention. Hey, it looks like an oscilloscope. Whoa, cool. So power cool. Okay, where are the probes? Ooh, right here. Look at that. Or there are some probes here, whatever. So we can put these guys in here. Hook this in here. Now you might say, oh, what are we going to be probing? Well, let's see. There are some ground points over here, but I think I might just see if I can clip it to this BNC, because if I don't wiggle it too much, it might stay there. And then I'm going to attach this to this, which should be, hey, a nice square wave output. Look at that. That's used for probe compensation. So check that out. It works. Oh, sorry. Yes. Brent made a, yes, he made a good point, which is that I misspoke. The capacitors on here are not tantalums, they're aluminum electrolytics. It's just a slight difference in chemistry. Both tantalums and aluminum electrolytics are both directional. Tantalums tend to be surface mount directional capacitors, and they have like slightly different capacitance ranges. And they also explode if you accidentally solder them in backwards, as it turns out. Yeah, so yeah, Oscope display. Thank you for that correction, Brent. I do appreciate that, because sometimes my mouth sort of like gets ahead of my brain. Cool. So let's figure out how to work this thing. We have buttons that say plus, minus, OK, and select. We have a button that's reset. We have a triggered LED, which is not lit right now, which makes sense because it's kind of rolling there. So I think I want to like figure out how to adjust the scale and how to adjust the trigger so that we have a nice like stable display on there. Yeah, super good. Super duper good. All right. Cool. Well, there's not a ton of explanation past that in the instructions. Was just like looking to see. Oh, okay, here we go. They do have like probe calibration and stuff like that. Cool. So let's see, we'll press the select button. Okay, there we go. Auto, that's fine. Triggering on a downward pulse, that's good. Maybe if I press up here while we're in trigger mode. No, it's not adjusting the set point. Okay. Oh, maybe. Is that? I think that should be the trigger. I would think. It seems to be that arrow, right? Okay. Oh, hey, there we go. Oh, okay, just held. That's kind of cheating. Okay. And then kilohertz, 3.3 volts. Interesting. Okay, so I'm not sure what I am adjusting right now. Okay. Okay, that is just overall offset. Yep. That's just our signal reference. Just curious what's interesting. I don't know. I'll probably end up checking this with another oscilloscope just to do that at some point in time. That's just the time division. How do I change the scale? I wonder. That. What is that? Okay, that's still hold. Interesting. Sensitivity. 1 volt, that seems to be right. Sense 2. Let's see, coupling is on DC, that's good. Yeah, so Bob, what I'm probing right now is the 1 kilohertz, and it's supposedly 3.3 volts, which is interesting because I feel like, yeah, interesting. I feel like this is showing a much higher voltage wave, but it might be that the scaling isn't quite right. So I'm trying to figure out how to like adjust both the trigger and the scaling, because it doesn't really seem to be triggering, which is surprising. Like I feel like it should be. So yeah, see if I can figure out, oh, highlight. So auto center trigger level, highlight trigger level indicator, and hold down OK button for 2 seconds. Trigger level indicator. Okay, so that's when, well, I think, yeah, that seems trigger at 9.86 volts. Interesting. Okay, I'm gonna hold down OK for 2 seconds. Ah, oh, okay. Interesting. Yeah, oh, hang. Maybe sensitivity, there we go, should be X1, I am guessing. I think that's like, it's basically like amplifying the signal is the sensitivity one. Let's see, probe calibration. Oh, interesting, to 0.1. Let's see, and switch to X5 to AC or DC. Aha, okay. So it's telling me what switches over here to set it out for the like proper probe calibration display. And then adjust time base. There we go, to 0.2 milliseconds. Other way. There we go. Look at that. There we go. And okay, then we can adjust the trigger level. Let's see. Yeah, that seems to be pretty good though. Okay, that's cool. And then, okay, so the sensitivity switches seem to adjust the scale, the voltage scale. Oh, and then there's a capacitor trimmer so that the waveform displays, yeah. Oh, okay, that is super interesting. So like, so yeah, so that capacitor trimmer is actually a probe compensation trimmer. It's sort of like assuming that you're using these alligators as probes, that there's no onboard probe compensation. So it's like, so the probe compensation is actually on the oscilloscope itself, which is kind of interesting. It's different from what I'm used to with like the probes that have the same kind of like capacitor trimmer built in, and you actually like adjust the probe itself. So, okay, that's kind of cool. Let's see. So I can do that. I'm just curious. So since the sensitivity to 1, interesting. I'm gonna have to like sit down a little bit more with the and figure out like the sensitivity deal, because yeah, it's not like super obvious to me what gives you like what the divisions are, and yeah, and like what gives you kind of like the right reading that you would expect, the right scale that you would expect. I wanna, let's see, put this guy, I'm gonna get it so that like the whole freaking wave is on the screen. Okay. Because yeah, I would be used to, okay, so yeah, all right, so that's 0.5 volts per division, right? Does that actually make sense? Let's see, and let me, the trigger's a little bit jumpy, I feel. So like I feel like this should be square enough to be triggering like a little bit more steadily. Let's see. I know I have tiny screwdrivers around here, so we can actually maybe do the probe compensation. Let's see, which one did it say? C4. So interesting. So that looks like it's changing the bandwidth a little, like making it a little bit narrower. So how much, let's see, how narrow should it be? What is it? Let's see. 1 kilohertz, 0.2 milliseconds per division. So yeah, that's not too bad. Interesting that it is on a negative slope trigger, yet, you know, I'm used to trigger being in the middle here, and I don't see where the middle, like where my start of the time base is. So I would expect like the falling edge to be right in the middle here, and it's not, which I think is a little interesting too. So yeah, waveforms they're not stable, just the trigger level, turn C4. So the waveform displays sharp and rectangular. Yeah. Let's see. So this is getting a little worse. This is getting like a little bit more rectangular and sharper, I feel like. But I'm wondering about the, like what the, interesting, the bandwidth should really be there. Interesting. 0.2, 6.5. Not enough, too much, good. Yeah, interesting. I wonder what there are actually two trimmer capacitors on here, and I'm curious as to what the other one does too. Yeah, try putting the trigger level, moving the trigger level around a little, see if that makes it any more stable. Yeah, I feel like it's just not triggering very well. I wonder if that is a, if we might have a little bit of a issue with our, let's see, with our, yeah, it didn't really help. Well, maybe. Yeah, it's still kind of moving though. I'm just wondering if we have like a assembly issue or if this is just kind of the best it gets. Interesting. Yeah, it should be like, yeah, I really didn't see much of a difference when I was adjusting that trimmer cap. So yeah, I don't know. I'll have to play with it a little bit more and like maybe read some more stuff online about it. And yeah, but it's kind of cool. I mean, you know, definitely, it definitely like is a little scope. Yeah, I agree, Brent. I don't think that I'm really triggering because it's like slowly rolling. So I feel like there's maybe a issue with the, like maybe with the trigger circuit. Maybe I'll like look back over those components and make sure that they're all like properly and well soldered. There is a schematic in here, so I can kind of like trace that signal line around. And I can just go, you know, looking at this under the microscope would also be a good idea, just to, you know, make sure that all the solder joints look good and stuff, and that there aren't any like little, you know, solder whiskers that are accidentally like half shorting anything out or anything. And I'll probably go all through this too and make sure that all of the voltages are what they're supposed to be. And I'll like verify that with a multimeter. And I'll also, you know, look at the signal with, you know, the other oscilloscope over there and make sure that it's not like the output itself that's jittering, right? So yeah, I think, but like, you know, so far not too shabby. Not too shabby. Like I'm, you know, if I can get that trigger working, I think I'll be pretty impressed with it. And yeah, and I definitely have to like figure out how the two sensitivities sort of work together to adjust the voltage scale. It's not what I'm used to, so I'm having like a little bit of a hard time wrapping my head around it. But yeah, cool. And yeah, I'll also have to see what the USB port is for too, because I don't think I even know what that's for. So yeah, like I wonder if I can, you know, I wonder if I can like send the output to a screen or if I can, probably not. It's probably just for like communication or programming or something, but yeah, cool. Cool. Awesome. Yeah, yes, it is a working kit. I would totally agree with that synopsis, Bob. It works. It does something. Maybe not exactly how it's supposed to, but it sort of works. I'm like, it's good enough for me for right now. What I'll try to do is I'll try to like look into this a little bit more between now and next week, and like hopefully next week I'll be like, oh yeah, you know, blah blah blah, figured it out, and here it is, all working. And yeah, I'll try to kind of do the same with the Nixie kit to actually program the time and have that going. So exciting. Stuff's working. 2 working projects one day. That's pretty good. Awesome. Well, thank you all for joining, and yeah, see you next week. Enjoy the rest of your week. Have fun like building something.